Okay, we start now. So yeah, good morning and good day to all audience and viewers from Massa University Facebook page and YouTube channel. Welcome to the webinar conducted by Faculty of Engineering, Built Environment and Information Technology, Massa University. My name is Bassam Hussam Abu Obaid, and I am a mechanical student in Massa University, and I will be serving as the moderator today. Today we will be hearing presentation from Mr. Surya Prakash Vijayasuriya. Mr. Surya has 7 years working experience in engineering industry involving biocomposting, bio, biogas plant projects, manufacturing precision gauge blocks. Mr. Surya obtained his degree in Bachelor of Engineering Honours in Mechanical of Engineering from University of Sunderland, UK. He completed Masters of Energy and Sustainable Development at De Montfort University, UK. And he has an industrial trainer with certified the trainer HRDF experience in conducting training based on smart irrigation system, Arduino technology, sustainable energy, composting and circular economy. His research area is focusing on smart irrigation using PV system and technology application for sustainable agriculture. Currently, he is working as lecturer of Faculty of Engineering, Built Environment and Information Technology at Mahsa University, Malaysia campus, associated with Anglia Ruskin University and University of East London. Without any further ado, I would like to welcome Mr. Surya, who will be speaking to us with the topic about smart irrigation system for sustainable future. All right, Mr. Surya, so the floor is yours and you can start.
Thank you. Thank you very much, Basam, for the very good introduction. Very good morning to all the professionals, professors, industrialists, and engineers. And thank you very much for viewing this YouTube live from Masa University, Faculty of Engineering, Built Environment, and IT. I myself, Surya Prakash Vijay Surya. Today, I would like to present a title, Smart Irrigation System for Sustainable Future. What is smart irrigation system? What is sustainable future? Why it is very important? How it is related to Industry 4.0? That is the important facts that I'm going to focus today. Looking at the title Smart Irrigation System, we have many different irrigation system applying in agriculture field. Why sustainable future? Why it is very important to sustainable future is irrigation development towards smart, okay, when there's a implementation of technologies integrating with the irrigation system, it will become a smart irrigation system, and it is very important for sustainable future. Sustainable future is very much aligned to sustainable development, which is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So we should not compromise with the future generation, and we need to focus more on the sustainability of it. Industry 4.0, looking at Industry 4.0, it is very much consist of artificial intelligence, cloud computing, automation, robotics, and also big data analytics. So all of these are main components of the Industry 4.0. Any of this technology, like autonomous technology or automatic technology or artificial intelligence implementing in the irrigation system, will turn the traditional irrigation system method to smart irrigation system. That is the main focus of our topic and subject today. Moving to the second slide of it. In recent years, some regions in Malaysia are facing water scarcity. We are having a lot of water difficulties, and also the supply of water and the energy consumption was also increasing every year. If you're looking at the recent research and topics, a journal published in 2022 and 2023, most of the journal papers are also focusing on how to reduce water consumption and also energy consumption. In Malaysia, water and energy management is actually an essential topic in agriculture sector, because why we need agriculture in not only in Malaysia, in other countries, because we are very much giving more priority for the food production. Agriculture is of one of the main food suppliers. So agriculture, the growth of the agriculture sector is very important for the growth of the food supply. So energy management and water management is very essential. According to United Nations, uh, they are more focused on sustainable development goals. That is why the smart irrigation system was designed as a solution to reduce the consumption of water and harvest clean energy for farmers. Not only focusing on the water management part of it, they also focus on harvesting clean energy, generating clean energy. For example, from solar panels, from wind energy, or from hybrid renewable energy sources. For example, what are the hybrid renewable energy sources? Like solar mixed with wind energy, or solar mixed with hydro energy. So this kind of technology integrating with traditional method of irrigation system will turn the irrigation system into a smart technology. Not only that, smart technology also addresses and promotes sustainable development goals, specifically focusing on sustainable development goal number 6, clean water and sanitation. Sustainable development goal number 7, affordable and clean energy. This 6 and 7, 6 is focused on more on water management. The sustainable development goal number 7 focus on harvesting clean energy, energy that does not pollutes the environment. Okay, and it is available for all the communities that need energy supply. Such the goal number 8, sustainable goal number 8, decent work and economical growth. How it applies in the smart irrigation system is when the application of smart irrigation system produces more um, food in the agriculture sector, produces more crop, and also able to manage water and energy at the same time, we creates more work opportunities, and people no need to do hard work. They will focus more on the smart work, for example monitoring the system, and also maintaining the system. At the same time also do analytics using the data collected from the smart irrigation system. And moving to the goal number 12, responsible consumption and production in Malaysia, we reduces water wastage in the agriculture through the smart irrigation system. When we reduces the water wastage and also produces more crops, that's where goal number 12 is very much related to the smart irrigation system. So smart irrigation system supports sustainable development goals. Moving to the next slide, I would like to introduce many methods which can also be said as traditional methods and also improvised methods of irrigation system. There are many types of irrigation system like center pivot irrigation, sub-irrigation, drip irrigation, subsurface textile irrigation, irrigation sprinklers, drip, irrigation tank, and micro irrigation. Looking to some part of it, if you look at the center pivot irrigation system, or we before we move on to the center pivot, we look at the surface irrigation system of it. This surface irrigation system been implemented in many countries, especially Asian countries. Looking in India, surface irrigation have three phases like advance, storage, and recession. What is advance? Advance where they start to on the water will slowly penetrate into the soil and it will flow into the field, okay, and moves down the channel. So basically the land will be slightly tilting to allow the water to move from the top to the bottom through the gravity movement. After that, slowly one end, once it moves from the top to the bottom at one end of the irrigation phase, it will start to collect and turn the whole area like a pond. So it will collect the water and it's like the ponded area, and later part they have a sufficient amount of water to supply to other areas. That is the first advanced stage. When we move to the storage stage where they store the water, remember when the water supplies and then it collects at the end of it, and slowly it starts to store the water. What happens when it stores the water? They will stop the water supply. After that, they will, when the land gets dry, okay, slowly this water that stores, it starts to supply to the dry portion of the lands around the agriculture field. And then and it has a sufficient length of time for the end of the field to receive the required depth of water. So let's say the plants needs water, it will take the water from the stored area, and after that irrigation water is turned off at the time of cutoff. Recession stage begins, where slowly the water starts to um what we say starts to supply water to other areas and moves down and then upper to the dry portion of the areas. So this is how the surface irrigation system works. Okay. And basically surface irrigation system consumes lots of water, but most of the agriculture which has a very big agriculture plantations, they use this type of method. Going towards the localized irrigation system, there's another type of irrigation system. It's a high efficiency rate that may be high productivity might lead to large water savings. So, for example, this localized irrigation system, it's focused on one particular plant. So, let's say we have 500 plants. Each part of it, the water directly supplies, and at the same time, it minimizes the water loss through evaporation from the soil. So, this localized irrigation system have like a kind like a hold on the pipe, and from the hole the hole is directly aligned to the root of the plants. So once it started, it will slowly drip drip drip, and this plant is surrounded with clay pots, porous clay pots, and these porous clay pots will allow the amount of water. Let's say it's already fill up, let's say the plant is already get a lot of waters, the balanced waters will move out through the porous clay pots, or we can also mention it as a perforated plastic sleeve, which means they will put the plants into the sleeve, put some holes, uh, uh, put it inside the soil, buried inside the soil, and then slowly when the water fills up the sleeve, the balanced water does not affect the plants and the roots. It will slowly run off through the other parts of the soil through these porous holes. So that is the main part, main function of the localized irrigation system. I won't probably say the main function of it, I probably say that is the way the system works. And then one of the most common types of irrigation system is the drip irrigation system. The most effective method of delivering nutrition and water to the crops is through drip irrigation system. Not only water supply, they also mix fertilizers with the water together, okay, liquid fertilizers, and then they pump it through the pipes. And through the pipes, if you can see, there will be some emitters. They call it as emitters. Slowly from the emitters, drippers. It's also they can call it as a drippers. From the drippers, slowly drop by drop, the water will be supplied to the field. So this drip irrigation, we can control the amount of drip. Let's say for per seconds, 2 to 3 drips, you want it to be in the soil, or for per second, 1 drip, or for per seconds, more than 10 drips. You can control by twisting the emitters basically. So direct nutrition water delivery to the plant's root zone offers farmers a quick and easy way to manage their field because their whole field is moisture. They can able to maintain the moisture content of the whole field. This irrigation system is very much focused on steady and balanced supply of water. That is why it is very famous irrigation system method and also efficient. Furthermore, the emitter slowly drip water into the soil at the root zone. First, it touches the root zone because the moisture level at kept at an optimal range. So, even though the field is very hot, even though the evaporation starts to take place, the water content will reduce, but at the same time, the root zone will still get sufficient water through dripping, drip, 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 drip. So that is the famous part of the drip irrigation system. Going towards one of a bit more advanced irrigation system, they call it as a center pivot irrigation system, a mechanical pressurized water irrigation technique. It's a center pivot irrigation system. Water is applied in a circular pattern using the first and most common type of pivot irrigation. Okay, why they mention it as a circular pattern is because they use a kind like a small sprinklers throughout the pipes. The water is supplied through the pipes. These pipes supply to the sprinklers, and the sprinklers will be hanging throughout the system from one end, from let's say from the east of the field up to the west of the field. So which means from the left hand side to the right hand side, they will fix it, the whole pivot irrigation system. The whole system will be hanging and the sprinklers will work. So they need pressurized water because if there is no pressure, the water won't come up from the sprinklers. Because sprinklers are, the disadvantage of sprinklers is less pressure, the sprinkle won't work. It will start to drip less water. Uh, but if let's say it start to drip less water, it will only focus on one area. If there is a high pressure, when the sprinkle spins, when it sprinkles around the area, most of the plants will get sufficient amount of water. That is the one of the challenges they are facing. And it is mechanical. Why mechanical? Because you can move from one part to another part, but but it consumes a lot of energy basically. And also it is one of the method that provides a lot of amount of water to the agriculture field. Moving towards the sprinkler irrigation system. Pivot system uses sprinklers, but we have another system only focus on sprinklers. It's just pins. You can see that these sprinklers is everywhere and they connected to the pipe. And if you turn on, it will start to sprinkle. You know what is the benefits of sprinklers? Sprinklers are not suitable for the soils which easily form a crust. Okay, but if the sprinkler irrigation is the only method available for the farmers, they will use the sprinklers to spray on top of the leaf. Okay, because the water is supplied from the top. When it hits the leaf, some water would not be hitting the root of the plants, but some, if let's say they just want the farmers especially, they just want the plants, the leaf to hit with the water, basically this sprinkler is sufficient. Okay, but as I mentioned previously, water should be distributed with high pressure, then only the sprinkler will turn and spin according to what pressure it is supplied. So the water is distributed through a network that may consist of pumps, valves, pipes, and also it is used for residential, industrial, and agriculture usage as well. So this is a sprinkler irrigation system. The larger sprinklers, we are going towards the larger sprinklers, it produces a larger water droplets because when it spins, it doesn't flow the water. It emits into a form like a water droplet. So the water droplet will be like sprinkled all over the area. Okay, so that is the one of the irrigation method that we're focusing now. And then we move on to the lateral move irrigation system. Lateral move irrigation system is something very similar to center pivot irrigation system. But lateral move it moves with the ability to irrigate two sides of a rectangular field. So which means one side at the same time it can move like a 360 degrees Celsius as well. It moves around the field. So that's why they call it as a lateral move. It don't only fix on one part of it, it moves. While it sprinkles, it moves. And the lateral motion system is unanchored. Why unanchored? Which is not fixed in one point. And they use a sprinkler method as well. Another good system, and we can also mention as a good technology, which is a sub-irrigation system. What is the meaning of sub-irrigation system? Which means the irrigation doesn't install on top of it. Irrigation basically they use pipes like HDPE pipes, they use PVC pipes and also other type of pipes. These pipes are not installed on top of the field. It is installed at the bottom of the field, which means they done installation first and then they build the field on top of it. So the runoff and the soil contamination can be decreased by recirculating the irrigation water. So the water will be flowing at the bottom of the soil and it will start slowly to supply water and the roots will grow towards the water. So they once the water is used, it will go into a chamber. From that chamber, the water will pump back to the field. So leachate from the benches or the ground beds, it's not allowed to leak into the soil. So for example, we have another chamber to collect the wastewater. For that is what they call mention it as the leachate. So wastewater contains fertilizers, unwanted dried leaf and everything collected in one part, filtered and collected. It won't disturb the recirculated water. So the water is still clean and it will start to circulate, and the wastewater will separate it into another chamber. And then the recirculated during the subsequent watering, water is distributed across the land by raising the water table through a system of pumping stations. As I mentioned, this needs a lot of water pumps with high horsepowers because it needs to pump throughout the whole field. And this type of irrigation is most effective in areas with high water tables. So this is how they use in high water tables where a lot of flood is happening. They use this type of irrigation method. And as normal in our homes, in our gardens, in our residential area, we use manual irrigation system. Most of the farmers, they use workers, they hire them just to manually irrigate all the plants. Until now, until today, you can see water is distributed across the land by raising the water table through a system of pumping station, canals and gates. But at the same time, manual irrigation also takes place. But it is a very hard work and it is not easy because how much manual irrigation system is being applied and not much crops have been produced. This is not from my point of perception, it is from the research. Okay, what is the benefit of irrigation system? The main benefit of irrigation system is to save time, save water and save money. These three things that farmers really focused. There are many other components to improve the technology, to produce more crops and everything. But the main 3 points was to save time, save water and save money. How they can save time is through the systems. Automatically it will on, it will off without much human interventions, and at the same time it only supplies sufficient amount of water. That is why it saves water. And because of supply constant sufficient of water, the crops start to produce and it also produce a lot of profits and it save money. And you don't need to worry about the water wastage, you don't need to worry about the energy consumption as well. The technology of irrigation system, farmers adapt and use efficient irrigation system. They will do a kind like a report for, let's say, the first year they use this method, how much crops are being produced. Second year they will try to improvise it. But if they see less profit, they will move on to a different irrigation system. So basically, they are focusing on the maximized farm level profitability. That is the term, profitability, through improved crop yields and decreased cost and other inputs like efficient irrigation technologies. Okay, by implementing efficient irrigation technologies, farmers are expecting to see their crop yields to be increased. But they normally will play this irrigation in three types of irrigation technologies, like gravity. They use the gravity, which is the, if you look, gravity method is the what you say is the surface irrigation system method. They use the gravity irrigation method. And sprinkler, we have seen the sprinkler. And micro, I think we have not mentioned about micro before. Micro means something that drips very tiny to small areas of the plants. A drip, it uses drip irrigation system as well, but micro is much more smaller than the drip irrigation system. And it's also only for certain plants that needs less water. Not all the plants need more water. Some plants grow with very less amount of water as well. Okay, this is all a traditional method of irrigation system. How this traditional method of irrigation system can turn into smart is by using smart technologies. What is smart technologies? Which is also aligned to industry 4.0. So these smart technologies, they use internet of things, okay, where they connected with internet, they monitor from other places. For example, let's say they fix the smart irrigation system in Kuala Lumpur in Malaysia, they can able to monitor at Perak, Malaysia, from other states as well, using internet of things. But they need a certain type of a microcontroller like Node MCU to able to connect through the internet. And internet of things, the very famous term is industrial internet of things, where the IoT is implemented in the industry. Let's say smart irrigation system is implemented in the agriculture field and it is working. It is basically can be said as an internet, industrial internet of things. Second is the artificial intelligence. How artificial intelligence? Let's say we have our humans, huh? Let's say farmers, just now I was mentioning one story, right? Farmers, for the first year, once they already see the profit, let's say they are getting profit around like 10,000 ringgit Malaysia, and they want to improvise from 10,000 ringgit Malaysia of profit to 20,000 ringgit Malaysia of profit, they will start to collect data. What are their disadvantages, how they can improve the technologies, how they can improve the technologies. Quarterly, not yearly, quarterly. So when they start to see this much of points, they need to do their own calculation. But artificial intelligence is not like that. It will do their, it will do the own calculation. It will gather all the data. It will do the analytics, and it will predict the next 1 year how much water the plant needs to use, how much water it needs, how much energy it needs to produce this much of crop. So it basically works um, behalf of human. That is why they call it as an artificial intelligence. Next is the variable rate irrigation. It's something they use sensors to understand the amount of moisture content and also weather forecast. And it uses a lot of variables to rate the irrigation efficiency, VRI. Next is the data informed decision making. This is a big data. What happens is they use a kind like a microcontroller like Arduino. They have a lot of different types of microcontroller. They gather only data of the soil, of the humidity content, of the temperature, weather, light, and everything. Once the data is gathered, it will give you a kind like a graph. So from the data, the system will give you a decision, and we will apply to increase the profit of the plants, I mean especially the profit of the crops. Okay, water management and soil management through wireless crop monitoring and control. This whole thing is actually a technology, but it uses sensors. It uses a soil moisture sensor to see the water content in the soil. It uses a soil sensor to see the efficiency of the soil. So all are these available, okay, in the market. And LoRa, low range radio frequency. It uses a low range radio frequency to transfer informations from one point to another. So farmers can use this type of technologies to monitor the whole field actually. And remote sensing monitoring, for example, remote sensing monitoring is very much related to IoT as well. And Arduino technology is a user friendly technology. You can code it using C++ and also Python in this platform called Arduino IDE, integrated development environment. So it's another kind of a microcontroller. And last, I probably would like to introduce the solar energy. Solar energy is a technology as well. They use it to harvest clean energy for the irrigation system. Okay, but since it's not stable, the generation of the electricity, that is why it comes together with the solar charge controller and also the battery system. Moving towards the industry 4.0, how important is the irrigation system for the industry 4.0? Have I ever been mentioning from the beginning of my topic? Industry 4.0 is a cyber physical system where everything is computer based. It implements Internet of Things. Automation takes place. How automation takes place? Smart irrigation system. You just turn it on and automatically it will start to work. Collects the data through sensors such as soil moisture sensor, heat sensor, and then light sensors, and then weather forecast sensors, everything, and then it start to work and then pumps the water according to the system that we programmed. Not only that, it also has cloud computing. This data, the smart irrigation sensor, when it collects the data, it can also store in cloud computing. That is actually, this whole thing is very much related to Industry 4.0. Let's say the agriculture field, the farmers, even the small farmers in the rural areas, they start to implement smart irrigation system in their agriculture business. Automatically, we already start to support and also develop Industry 4.0, which is the in Malaysia. Okay, Industry 4.0 in Malaysia. As I mentioned, what is smart irrigation system? Smart irrigation is a method of using science and technology to save water in irrigation. It contains weather sensors, as I mentioned. It contains sensors, weather sensors, soil sensors, and various controllers. The sensor monitors the current weather conditions and the actual ground humidity, and the controller controls the water valve to open and close. But however, we need a microcontroller. That microcontroller is being programmed, and once it receives the data, for example, it receives the data from the soil moisture sensor saying that less water, automatically it sends signal to the relay part of it. That relay will open the valve and automatically will supply the water. If we successfully already achieve Industry 4.0 in Malaysia, we must start to move on to Industry 5.0. The difference between 5.0 and 4.0 is a lot of smart system been taking place. Mass customization. Mass customization is not much related to the agriculture, because it is very much related to additive manufacturing, where usage of 3D printing. But there might be some areas where we need a lot of development focusing on mass customization for agriculture business. And cyber physical human intelligence and cognitive system, where the complicated system like artificial intelligence can provide 1 week of forecast. Maybe in the future it can provide more than 10 years of forecast. So more complicated data collection, more complicated system taking place, than it is started to develop Industry 5.0 in Malaysia. So as mentioned, even though in the years Industry 1.0 started in 1784 and then move on to 1870, where they focused on the mass production, lot of industry takes place. and slowly they start to implement the computers, where the industry 3.0 start to be developed. Computer electronics and automation started, and from 3.0 slowly move on to industry 4.0, where the smart manufacturing takes place, and then smart system adoption takes place. And after that, a lot of complete complicated systems implementation, the industry 5.0 will start to take place, where we will have very very less human interventions. Most of the humans will be working on the as an expert, like controlling, maintaining, programming, so something like that. So the future is industry 6.0. According to my perception, industry 6.0 is the future, is just an imagination, like a dream. For example, how's industry 6.0 smart irrigation going to be in industry 6.0? Who knows, maybe a floating solar irrigation system, maybe flying solar smart irrigation system, artificial hybrid irrigation system. Maybe the hybrid system consists of 3 to 4 renewable energies, uh, including wind turbine energy, solar energy, and then thermal energy, and also hydro energy, a complicated system. And then all the houses, all the buildings might be implementing a very low cost and also user friendly smart irrigation system. Might be or might be not, we are not really sure. A lot of scientists and researchers are developing towards this industry 6.0 as well. And this is the samples of the irrigation system. If you can see, that is one of the soil moisture sensor, and we have the pump. That pump is basically used for to pump out the water. And we have a relay and DHT sensor. The blue color in the middle is called a DHT sensor, where it collects the humidity and also temperature at the same time. And we use Node MCU. Okay, and also you can see that under the serial monitor you can able to see the graph of the amount of humidity and the temperature it able to connects. So all of this we can say as a IoT system, the basic structure of IoT system. And at the same time we also can connect the IoT to through Bluetooth. Through connecting to the mobile phone, you can also view through the app applications, which means the how much is the moisture content, how much is the temperature. If a certain temperature is reached, certain temperature, a certain moisture percentage is reached, automatically you can turn off and turn on without going to the field. You can turn off and turn off from your home. It's just a sample I'm just showing. And IoT irrigation system, as I mentioned, it uses a lot of sensors. Okay, and thank you very much. As I mentioned, why I'm showing sustainable development goals is because smart irrigation system promotes and addresses not all of the sustainable development goals, but it supports sustainable development goals, which is already been suggested by the United Nations. So in Malaysia and also in developing countries, smart irrigation system is the future to increase the production of crops, profitability, and also increase the thank you.
Thank you so much, Mr. Surya, for addressing this interesting presentation.
Basam, can you hear me?
Yes, sir. Can you hear me? You can hear me?
Yes, I can hear you.
Yeah. Thank you so much for
Yes, I
this.
can hear you.
Thank you so much for this interesting presentation. And I have few questions regarding on this topic. So I want to ask you. Okay, I guess Mr. Surya is having problem with the connection. Okay, so thank you so much for your explanation, and we have come to the end part of your presentation. Thank you so much, Mr. Surya, for addressing this topic and for sharing this session. Hopefully, the presentation was beneficial for everyone. And on behalf of Masa University, we would like to thank you for joining us today. Thank you for your time and cooperation. Goodbye and have a good day. Thank you.